Alright, this is Ken Rosever. We're going to talk about normal distribution word problems. Here is a problem taken from Alex. According to a recent survey, the salaries of assistant professors have a mean of 41,750. Wouldn't that be nice? And a standard deviation of 7,000. Assume that the salaries of assistant professors follow a normal distribution. Find the proportion of assistant professors who earn at most $50,000. So we want to find P of X, which is our raw score, being less than or equal to $50,000, because it says at most $50,000. Okay, in order for us to do that, we're going to have to convert this $50,000 raw score into a standardized score, a z-score. So how do we do that? Well, we know that the mean is 41,750, and we know this 5,000 is to the right of it somewhere. The standard deviation is 7,000. So we simply plug this information into the formula that says z equals the raw score minus the mean over the standard deviation. Okay, so X is 50,000. We're minusing 41,750. We're subtracting 41,750, and we're dividing the difference by 7,000. So let's do that really quickly using the Alex calculator. Let's go over here. So it is 50,000, that's our value of interest, minus 41,750 divided by what? 7,000. And that gives us our z-score. It's 1.178. I'm going to leave that in the calculator and write it over here. So my z-score is 1.178. So that's about right here. 1.178. And I'll erase this stuff. Okay, so that's 50,000. But we're not interested in the probability of exactly 50,000. We're interested in the probability of at most 50,000. So 50,000 or less. So which side of this, if I asked you to shade it, would you shade the right side or the left side? Well, just because you see a most in there doesn't mean more than. No, it means, like I said over here, it's less than or equal to, at most. So the most it can be is 50,000. So we're looking for this area to the left. And that's convenient because we know that both the table works that way. So I could just look up 1.178. I can't look up 1.178, but I can look up, let me erase 1.18 in the table. And when I do, let's see, I have 1.1, 0, 1, 2, 3, 4, 5, 6, 7, 8. So there's my answer. 0.1190 is the answer. Also, I could do it using the Alex calculator, which is actually rather quick, because I can just hit P of this, and now it takes my previous answer and just slides it into that box. P of z less than or equal to 1.178. And we notice when we look at this too, the left side is shaded. So that's consistent with our picture. Once again, the left side is shaded when we hit that button, consistent with our picture. Okay, so all I have to do is hit equal, and that is the percent. 88% of professors earn at most $50,000, so 50,000 or less. But we're going to write in all 4 decimal places, and that's that. Before I go on, I'm going to show you can do this all at the same time. You know that in this box you have to put a z-score. So in the box we can put 50,000 minus 41750 divided by, it only divided the last thing, so I better put a parenthesis here. And maybe I'll hit divide now, and now it's dividing everything. That's what I want, divided by 7,000. So you can put that all in the box and then hit enter, and you get the same thing. It'll do it all at once. So that's it for that one. Let's do another one. Now, it's really important that you always draw the picture just to make sure you're understanding if it's the left side or the right side. All right, here we go. Suppose that the annual rate of return for a common biotechnology stock is normally distributed with a mean of 5% and a standard deviation of 5%. Find the probability that the 1-year return of this stock will be negative. Round your answer to at least 4 decimal places. So it's normally distributed. So again, we can go to here. Here's the problem. They want to know the probability that'll be negative given that it has an annual return on average of 5%. So what does that mean? On average, this stock pays you 5% every year, 5% of your investment, however much you own in the stock. And the standard deviation is 5%. Well, that's actually, let me not write it like that. Let me just put 5%. And the standard deviation is 5. So what does that mean? According to the empirical rule, 68% of the time, it's between 0 and 10. And actually, you can just very easily do this without even having to do much with z-scores, just by using the empirical rule. You know, it's 68.2% will be within 1 standard deviation. So divide that in half, and that's 34.1, which leaves you with 15.9 or 0.159. Alright, so that's my estimate. But to actually get the answer, it's very easy to see that that's 1 standard deviation. But if you weren't sure, you could go z equals. We want to know when it will be negative. So we're interested in the probability that the value will be less than 0. Okay? And so we're looking, our value of interest is 0 and minus 5. I'm ignoring the decimals here. And over the standard deviation is 5. So you can see that's the z-score is -1. So that equates to p of z less than -1. And we can look that up on the chart. Here's the table. And -1 is right here. -1.00 is right there. 0.1587 is my answer. And I said 0.159. Actual answer, 0.1587. Okay. Using the Alex calculator, we can do much of the same thing. Here we go. Alex calculator. Here's the problem. Let me move this over. We're going to do P of Z less than. Let's put it in parentheses. First, we need the z-score in there. Of course, we already know what that is. It's 0 minus 5 over 5, which is just -1. So when we hit enter, we get the same thing. 0.01586, so we round that 6 up to a 7. 0.0187, or 0.1587. Why am I saying 0? 0.1587. Okay, and that's it. Very straightforward. One more time. Do I have time? Yeah. Okay. The last problem here says, suppose that the time required to complete tax return has a mean of 100 and a standard deviation of 50. What is the proportion of tax returns that will be computed in less than 120 minutes? So again, that's going to be shaded to the left because we're looking for less than 120. And our answer is going to be P of Z of 120 minus, I need parentheses, don't I? 120 minus 100, close the parenthesis, divided by 15, enter, is 90.87%, 0.9087, and we're done. So that's it.